Good morning, this is your Stat Sensei, Mr. Spensei, and this is classical probability and Venn diagrams. This will be a long video, so we're going to break it into two. And here we go. In this textbook, 48% of the pages had some kind of data display. So we know 48% had data. And 27% had an equation. So equation is 27%. And then we have the next category with 7% have both. Okay, this gets a little bit tricky when we go to actually write this out. And if we have a both, that's probably where we should start. So basically, this is 7%. Please remember, always divide percents by 100. When I divide 7 by 100, I get 0.07. So that's my both. My data display, we want to write 48%, but that's actually incorrect because we need to look at this and go, you know what? In the data display part, the data display includes the both. So for the data display, this part right here is not just going to be 48%, it's going to be 0.48 minus 0.07. So minus that overlap, minus the both, which gives us 0.41. All right. So 0.41 is how much is in data only. Now, 48% is data, but 41% is data only, not both. So then we have the equation side of things, and we have to do the same type of thing. With the equation side, once again, we have that both, and that both is 0.07. So with my data side, my equation side, it's going to be 0.27 minus the 0.07. And when we get to that, that gives me 0.20. So while equation is 27%, that's still true. The equation only is 0.27 minus 0.07, which is 0.2. Well, if I add those up to be a valid probability distribution, it has to sum up to 1. Okay? So when I add these three values up, 0.41 plus the both, so this is data only, plus the both, plus the equation only, this needs to add up to 1, and I don't think it does. So if I go 0.41 plus 0.07 plus 0.2, I get 0.68. And so that equals 0.68, which means there must be some other missing because it has to add up to be 1. So the neither part, the part that doesn't have a data display, doesn't have an equation, doesn't have a both, is 1 minus 0.68, which equals 0.32. So this is 0.32, and once again, that's just the total of these minus 0.68. All right, I'm going to put up the pretty notes now that since I've set those up so that you can see it look a little better. Okay, so there we have, once again, the actual data minus the both gives us this total. So this is data only, this is both, and this is equation only because it's the equation minus the 0.07. And we express that this was 1 minus 0.41 plus 0.07 plus 0.20 is 1 minus 0.68 equals the 0.32, and that's our neither. Okay, What percent of pages had either a data display or an equation or both? Well, this is where we have to use our, and by the way, the word or tells me I'm adding. So this is going to be the probability of A union B equals the probability of A plus the probability of B minus, and I'm running out of room, so I'm just going to put the intersection sign. Okay? Now, in our case, instead of A union B, it's data union E equals the probability of D plus the probability of E minus the probability of D and E. You know, I have a little bit of room here, so I'm going to go ahead and write it here. Probability of A, oops, probability of A union B, because this will be on your formula chart. We will give you this formula. You're not expected to memorize it, but you do have to know how to use it. I'm going to scratch that out just because it's crowded. Minus the probability of A and B. And is my overlap. That's where the streets cross. That's the intersection that we've dealt with before. So that's going to be 0.07. So in this case, we have D union E. So the probability of data, well, probability of data is 0.48. The probability of an equation is 0.27, but we have to subtract out the intersection. And the reason we have to subtract out the intersection is if I go back to my original drawing where I was drawing it out, we notice the intersection got crossed twice. Okay, the equation got crossed once, but the both part, and I could use colors and maybe that'll help. So the data section, if this is the data section, it got covered in pink. And then I come back and if I cover the equation section, we notice the both gets counted twice. And because it got counted twice, we have to subtract it out. So when we subtract it out, we get 0.48 plus 0.27 minus 0.07 is 0.68. And guess what? That's what we got when we added just the individuals. All right. So what percent of the pages had neither a data display nor an equation? Well, we already solved that. We added up the probability of D union E, which is 0.68, and we know we have to have a valid probability distribution. So 1 minus that probability gives us 0.32, and that's where our neither comes from. Next, what is the probability of selecting a page which has a data display but has no equation? Well, when I look at it, data display is 0.41 or 0.48, but the part that has no equation, I guess I really should be using green. The part that has no equation is just this part right here. Well, how much is that part? Well, that part is 0.41 because it's the data minus the overlap. And we're subtracting out the overlap because the overlap includes equations. What's the probability of selecting a page has a data display given that it has an equation? Okay, so what were we given? Remember, it's always intersection over given. So if it's intersection over given, we were given that it has an equation. Well, what's the probability of an equation? Well, we know the probability of equation when we look up here at the top is 0.27. But I need the overlap. Intersection also means overlap. So I need the overlap, and the overlap happens to be 0.07. So we end up with 0.07 over 0.27. Okay? Next, what is the probability a selected page has an equation given that it has a data display? Well, what were we given? Remember, it's always intersection over given. And what we were given was we had a data display. Well, what percent have a data display? 0.41. Oh, excuse me, 0.48. From up here, 48% have data display. But, and we need the whole data display. So the 48% have a data display. Of that 48%, which have both, because the both is where we have the equation, and that happens to be 0.07, because once again, we're looking for the overlap. The intersection also means overlap. It's where the two circles cross. So we end up with 0.07 divided by 0.48. What's the probability selected page has no data display, but has an equation? Okay, so in this case, we want the equation only. Well, what is equation only? Equation only is this part that I'm circling here in pink. An equation only is 0.20 because it's the probability of the equation, which is 0.27, minus the overlap is 0.2. The next thing is it asks, are selecting a data display with a page equation mutually exclusive. So are selecting a page with a data display and selecting a page with an equation. So with a data display, with an equation, mutually exclusive. Well, to be mutually exclusive, there can't be an overlap. Well, in this case, we have an overlap. So no, they cannot be mutually exclusive because there's an overlap. Since the Venn diagram has an overlap and both equation and data display can be on the same page, this is not mutually exclusive. Matter of fact, how often does it happen? It happens 0.07. Because we have a 0.07 chance, if this is anything but zero, if the circles overlap, to be mutually exclusive, they have to look like this, no overlap. But if you have an overlap at all, not mutually exclusive. To be mutually exclusive, they have to be two separate circles. Are selecting a page with a data display and selecting a page with an equation independent? Okay, this requires a new formula. Our new formula is going to be the probability of the intersection, the probability of A and B equals the probability of A times the probability of B. But we're not working with that. We're working with D and E. So the probability of the intersection, which is 0.07, has to equal 0.48, the probability of data, times the 0.41. So let's do that. When I take my calculator and I go 0.07, excuse me, 0.48 times 0.27, I get 0.1296. So this is not a true statement. They have to be exactly the same. And since they're not the same, they are not independent. They have to be exactly the same. The next thing it asks us to do is create a contingency table for the above. All right, so with the contingency table, how much had data? Well, on the data part, we know we had 48%. This is all on the screen. There we go. On the data part, we know we had 48%. So this is 0.48. Okay. On the equation part, we know we had 27%. So this is the 0.27. And once again, these values came from those shaded portions. Then we have, what's the probability of having both? Both was this center section right here. And both has to be 0.07 because that's where they overlap. So this is going to be 0.07. And you know what? There's something I skipped here, which is the easiest part. So I should go ahead and do the easiest part first. The easiest part is this is going to be one whole every single time, 1.0. Okay, so then we have data. Well, guess what? These have to sum together. So what's 0.48 minus 0.07? Oh, that's that 0.41 that we have here because this is 0.48 minus 0.07. All right. Well, guess what? What's 1 minus 0.48? 1 minus 0.48 is 0.52. And while we're here, what's 1 minus 0.27? 0.73, because this plus this has to equal this. This plus this has to equal this. This plus this has to equal this. And guess what? This plus this has to equal that. So I can go, well, you know what? If that's the case, then I can go 0.73 minus 0.41 equals 0.32. Now, that's an interesting number here, and I'm going to circle it because that's our neither, because that is no data and no equation. So that also shows up. Amazingly, I know this isn't really shocking to you, but this is going to be is going to be 0.27 minus 0.07, and 0.27 minus 0.07 gives us 0.20. And 0.2 plus 0.32 is 0.52. So all the rows and all the columns have to line up. So here's what it actually looks like in pretty without showing the calculations. But this plus this equals this. This plus this equals this. This plus this equals this. This is a typo. This is 7.3. And then this plus this equals this. So I can add up going across, and I can add up going up and down. Okay, I hope this helps. Look forward to seeing you on the next one when we do part 2.